All right, good morning. So welcome back to pre-calculus. This is a problem I got out of another book. It's a system of nonlinear equations. I urge you to try it first before you watch me do it. Okay, it's just one of those things that you kind of have to make the mistake yourself in order to learn from it. Okay, so yes, we're all going to make mistakes on this, but because I'm going to give you I'm going to show you how to do it. Just a second here. There's no consequence for you making a mistake like this. So it's there's only an upside here. So try to do something like this on your own. I don't know if I would pick quite this hard for your final exam, but this is close. Okay, this is real close to the order of difficulty that I would say, oh, this is a good linear equation for me. So how do you do something like this? Okay, I love this problem because hey, it's got logarithms in it. It's got all the fun things in it that will let me test you on multiple skills at the same time. So we've got natural log x to the fourth. Okay, should have written this down before we started. So we have ln x to the fourth plus, and it looks like we have a 3x squared. 3x squared equals 1. Equals 1. And then we have natural log x cubed. Okay, so we have natural log x cubed plus, I think it's 2y squared. 2y squared equals negative 1. Plus 2y squared equals negative 1. So we have to decide what strategy are we going to use here. Normally, we would say substitution is probably a good choice, okay? But in this case, even substitution looks a little gross, okay? Maybe we can substitute for y squared. That's a possibility, but I'm still going to have to deal with like fractions and stuff like that, substitute the back end. So I'll tell you what we're going to do. First off, do you like natural log of x to the fourth? Do you like natural log of x cubed? No. Is there a way we can simplify that? There sure is. So what we're going to do is we're going to use our rules of logarithms to pull down this exponent down to the front. So we're going to say this is 4 natural log x plus 3 y squared is equal to 1. Same deal. So we have 3 natural log x plus 2 y squared equals negative 1. Now this right-hand side isn't really doing very much for us. I mean, we can kind of distribute the negative sign. That might not be a bad idea. I'd say 1 equals negative 3 natural log x minus 2 y squared. And then what we could do is we could set these two equations equal to each other. Here's where that's going to be a problem. It's because even though I've done that, I'm still going to have one equation with x's and y's in it, and that's going to suck. So that's not going to give us that's not going to get us to where we want to go. Okay, so whereas that's not a bad choice, it's not the best choice. So what I would do instead here is, well, let's put that on the maybe pile. Okay, and that's okay. So what I'm going to do is I'm going to multiply this whole equation here by negative 3. Then I'll multiply this equation by positive 4. And what that's going to do for me, it's going to give me two equations where I can now say, okay, this is minus 12, 4 times negative 3, natural log 12x, okay, minus 9y squared is equal to negative 3, or is equal to negative 3. And then we're going to have a positive 12 natural log x, 12 ln x, okay, plus 4 times 2 is 8. 8y squared is equal to negative 4 times 4 times this, which is going to be 1. Sorry. Oops. There we are. It's equal to negative 4. Okay, and this is what I'm going to add up. Now, what this is going to do for me is going to give me, okay, well, negative 1, okay, plus 8, that's going to be negative y squared. And then what are we going to have? 4 and 3, that makes negative 7. So maybe not the nicest number in the world, okay, but y squared is equal to 7, or y equals plus or minus root 7. Okay, but right now what I have is y squared is equal to 7. we could still use this fact to plug into one of my equations here and still get another answer. So you can take this fact here and plug it into either one of the original two equations. Okay, how about we plug it back into equation one? Doesn't really matter which way we go. All right, we just want to plug it back into one of the equations. Okay, so we're going to say 4 natural log x. So we're going to say 4 ln x, okay, plus 3 y squared. What the heck is y squared? Times 7. Does it matter that y is plus or negative? Like when I square it, I'm always going to get that positive number, aren't I? So even though I know there are two solutions for y, for the moment, I'm going to set one of those aside. I'm going to say, you know what? That's great that it's plus or minus root 7. For the moment, I'm just going to say it's 7. Y squared is 7. And say this is equal to 1. 3y squared equals 1. And then we have to solve this. So we have 4 ln x plus 3 times 7 is 21 equals 1. Subtract 21 from both sides. So we have 4 ln x equals 1 minus 21. That's going to be minus 20, I believe. Divide both sides by 4. Okay. Does that sound when you do it? So we have ln x equals negative 20 divided by 4. That should give us negative 5. So one of the questions I have for you, is it possible that the natural log of x could be negative 5? At this point, I'm going to say, hey, remember what natural log x graph looks like? There's an asymptote here, crosses, looks something like that. Here's the line y equals negative 5. Oh, wait, they intersect. It is possible for this to happen. So while you're doing this problem, you do want to think to yourself, like, is this a no solution sort of a situation? Because sometimes when you get to, if you've not had your first coffee yet, you're working on this, you're like, no solution. Does that make sense? Like, well, in this case, if I got no solution, no, it wouldn't make sense. I know I'd screwed up. So I could say, how do I undo the logarithm, right? How do I unlogify all of this? So we say, okay, well, x is equal to e to the negative 5. So would that have mattered? Like if y were my positive root 7 or if y were my negative root 7, would that have led me to a different conclusion for my x's? Okay, think of it like an x rather than like cut off y. No, it wouldn't have mattered. So both of those solutions stand. It's just that we are different spots. The x value is going to be the same, but the y is going to have two different values. So what is it going to look like? Is we're going to have some kind of a weird curve where it does something like this. And we're going to have like a thing here. Okay, where my x value is e to the negative 5. Clearly not drawn to scale. And we've got a positive value and a negative value for our solution here, and that's how we're going to get our two solutions. So our two solutions are e to the negative 5, the square root of 7, and then e to the negative 5, negative root 7. Okay. Notice on the problem, it did not say graph the solution. Okay. When I did all of my math homework and all of my math classes, like back in the early 20th or back in the late 20th century, not the earliest 20th century, that old. We spent a lot of time on graphing. You guys don't, that's not the requirement for any of your classes. Okay, we have graphing calculators now, we have Desmos, we have all sorts of tools to help graph us. I did not have that when I went to college in the 1980s. Okay, so a lot of our educations were spent learning how to graph so that you could make a drawing, a decent drawing of what's going on. But that is not the requirement for a 21st century student. You guys have other tools to do this rather than spend weeks and weeks and weeks learning how to graph, because there were classes where it took weeks to graph. Okay, we have to get little compasses, we have to graph things, we have to plot them on like graph paper and be very careful. You could tell all of my attention to detail with my graphs now. Okay, but we would have to spend a lot of time, a lot of effort graphing, which thankfully that is a relic of the 20th century and before. but you guys don't have that kind of environment. I would not expect you to be able to look at this and then say, well, how would I go about figuring out how to graph this? That's not the requirement. So yes, I graphed it. Wouldn't ask you to graph it, but I would ask you to solve it. So I think for you guys getting these two answers, okay, that's where the standard is. That's where the requirement is. So if I put this on your final exam, I might lose a little bit of sleep because I think, well, that's kind of a hard problem for a final, but it's not that hard of a problem for a final. So again, I urge you, if you've gotten this far, you clearly didn't try this yourself first, but if it's on your second time, like see if you can't like make sure that all the steps are making sense. But see if this doesn't work out for us. Okay, so thank you for tuning in. I will see you in the next video.